case anybody will. By the way, I've been uploading these lectures to the internet and stuff. So if you're interested, they're on Canvas. You don't have to, but it's a pain in my ass to do it. Did I say that, Alan? But anyhow, they're there. I'm kidding. It's not. Well, it's time consuming. It's not really difficult. So anyhow, what I like to do is I'd like to do at least one more, maybe two problems. So yesterday we did two examples. We did a box problem and a rectangle problem. And so today we'll do one that I like to call distance problems. We'll start with that. So let's do that. So let's determine the point on the line y equals x plus 5 that is closest to the point 10, 0. So what I'd like to do at first is let's draw what this sort of looks like. That is a bad straight line. I guess I'll use the straight line tool to be the optimal way of doing this. So I'll draw my XY axis. I'm going to draw a line, y equals x plus 5. So this is likely not going to be the scale, but that's okay. So let's call this point this is the point 0, 5. And then out here, for example, let's say this is point 10. So we're interested in this point. Maybe I'll extend this so we can be. And then this is the point. Again, this isn't the scale. This is the point 10, 15. So here's the idea. We have this blue line and we have this point down here. This is the point 10, 0. And so what we'd like to know is we know that at least we understand that there has to be some point right here that minimizes the distance to the point 10, 0. We understand what the problem's asking. So again, I can draw a line from any point on that blue line to the point 10, 0. There's the two lines. Maybe I'll draw another one over here. So what we're saying is, and let's label this, this is some point. We'll call it C comma, what is this point? This would be C comma, C plus 5, if you will. Well, actually, let's not call it that. That's silly. Let's call it just for, why make it harder than it has to be? Right now, this guy has some coordinate. It's x comma y, correct? All right. So in order to solve this problem, we have to think about how do we measure distance in the plane? Well, there's two ways to think about it. The first way is to think about, being that I've drawn lines, you can think about triangles. You could say, okay, how do I determine how far? You know, the red line or the red segment has a specific length. The green segment has a specific length, and the pink segment has a specific length. Which one is the shortest and why? Now, obviously, there's more than three options. I'm not saying that these are just three options. I'm drawing three examples. So here's the way you need to think about this. So let x comma y be any point in the plane. Then the distance from x comma y to the point we're interested in, 10 comma 0, is, well, this is stuff that's long before calculus. This is the square root. You take x minus 10 quantity squared plus y minus 0 quantity squared. That is the distance formula. So that tells me how far apart any point x comma y is from the point 10 comma 0. Now, we're not just interested in any distance, right? So this formula right here, this gives us the distance from any particular point in the plane, but we're not interested in any particular point. We're interested in points that have a certain property. They have to live on the line. So we are interested in points that are on the line. So if x comma y is on the line, y equals x plus 5. We can rewrite d as a function. Now d is a function of x. Why? Because I can replace y with x plus 5. So this function right here tells me the distance between every point on the line and the point 10 comma 0. That's what it does. So if I go back to my picture, this guy right here, the length of this line is just d of x. That's the length of that line, d of x. And that's what we're trying to minimize. Chemical time. What chemicals you got today? Is that just water, Jen? I always have water. Water's my favorite thing. I shouldn't say this because it can come back to haunt me, but that's the reason I don't feel bad drinking these, because I drink so much water. I feel like all the bad that's in here is washed away. That could be a bad way of thinking, right? Although Rockstar, if you're out there, pay me. I drink these all the time. I'm corrupting the youth. This is like the equivalent of cigarettes, right? What an addiction. Okay, does anybody have a question so far? Comment? Let me say this one more time because I think it's important. This function right here, d, you give it an x. And then when you give it an x, it finds the corresponding point on this line, and then it measures the distance between that point and 10 comma 0. And so what we want to know is which one is the shortest. If you look at this picture, if you just look at these three, the pink, red, and green, our mind tells us that the red's the shortest, but I mean, it just looks that way, right? But we don't know that to be sure. And also, I don't know anything about x comma y other than it looks like it's in there. By the way, this is a problem that can be solved using geometry, but we're going to use calculus. Turns out the way to solve it using geometry is it's the only line that's parallel. You find the parallel line, or excuse me, the perpendicular line. But we're going to see that using calculus. Okay, so this is our function. We want to minimize it. So what we're going to do is we are going to have to first rewrite it. So let's do the following. Note D is also, well, let's remind ourselves, because that's important too, that it's a function of x. So it's the square root, and inside I had, over here I had x minus 10. So let's write it out again. Let's do the algebra together, plus the quantity x plus 5 squared. And so if we do some algebra, this becomes x squared minus 20x plus 100. And then over here you get plus x squared plus 10x. So I'm multiplying these squares out, and then it's plus 25. So if we combine our like terms, we get this atrocity. 2x squared minus 10x plus 125. Now, what should our domain be? Well, can we restrict our domain? Is there a smallest or largest x here? There's not, because this is not a geometric problem where we're not talking necessarily about, let's be more careful. We're not talking about like the length of a box or its width, but you have to understand that what I have in this square root, this only makes sense if what's inside is positive. So there is a domain here that we're restricted to. So what is the domain? Well, the domain is all x satisfying. Now, I'm not going to write this out because I'm going to reason differently. It's satisfying that 2x squared minus 10x plus 125 is greater than or equal to 0. So it's not important to me right now that I need to know specifics about that. And I'm going to tell you why. You could figure out exactly where x could live. But let me write that a little clearer, because that's an important fact that I hope you understand the necessariness of. Does that even make sense? Why it's necessary we do that. So in order for this function to make sense, this has to be true. Does anybody have a comment, question? I need to think of another thing to prompt you with so that you freaking talk. I hate the fact that you guys have masks on. I can't see your facial expressions. I feel guilty because I don't have one on. Of course, I told you many times to yell at me if you think you want me to have one. I'd be happy to wear it. I mean, talking a lot, it ends up driving me nuts. But. Okay, so what we need to do is let's reason that this thing does have a minimum, and let's reason that let's think about how we're going to do it. So to determine the minimum, so let's think about it this way. So let's determine the critical numbers. These are our candidates for minimum. So these are the solutions to the derivative equaling 0. So here's how I'm going to do this. By the way, I don't know how you guys like to think about differentiating something like this. There's kind of two standard ways of doing it. You can leave it as a square root, or some people like to write it as parentheses to the 1/2 power. I don't know what's easier for your brain. I know for me, when I think, you know, it's probably a little easier to write it. You know, what I mean by the square root is, I mean, some people might write this as 2x squared minus 10x plus 125, the whole quantity raised to the 1/2. That's one way to do it. It doesn't matter how you think about it. Either way you think about it, what's the derivative? Well, the derivative is, I like to think of it, so this will be, it's going to be 1/2 times the square root of what's inside. Now, I'm going to write this down here in English. I don't care what's down there right now. I don't. It's irrelevant to me. And I'm going to explain why in a second. But I do care about its derivative. And what's its derivative? Its derivative, if I go back to the previous page, is going to be 4x minus 10. Now, why am I saying I don't care? I mean, I know what it is. It's 2x squared minus 10x plus 125. I know that. But that doesn't help me because it's in the denominator. The only thing that can tell me is that I have some asymptote in my derivative. It has nothing to do with finding maxes or mins. Do we understand that? So in this particular context, the only thing that I care about is when this derivative equals 0. Now imagine, and imagine if, think algebra only, and I'm going to erase this in a second, but just ponder this. If I have 1/2 times something, and then times 4x minus 10 equals 0. Well, what would I do? The first thing I'd do is I'd multiply everything by 2 star to get it to the other side, right? So this right here is just equivalent to 4x minus 10 equals 0. Solutions to this, solutions, not bad things, but solutions. Solutions to this are the same as solutions to that. So what I'm telling you is I can ignore that because this solving what I have written in the first line is the same as just solving this, which of course is the same as saying x equals 10/4 or x equals 5/2. So if you have a comment or you have a question, please let me know. Question. Another reason I don't care to write this down here, I could write it, but I don't need to, is any point that makes this 0 wouldn't be in the domain of my function anyhow. So it doesn't make sense in context. So I don't have to worry about it. Do we understand that? Now, the only thing that's left is to verify that this is a minimum. In fact, we need to, what we need to do is verify that it's an absolute minimum. Now, how do we verify it's an absolute minimum? Well, let's just look at it. Notice, look at my derivative. Can this thing ever be negative? No, over here it can never be negative. So what we know is that the derivative only changes sign once. It changes sign possibly at 5/2. And in fact, that's where it's going to change, because pick something like 0. Plug 0 into this. So note, what is d prime of 0? D prime of 0 is clearly negative. And then also note, say d prime of, say, 5 is clearly positive. Don't overthink it. Just all you need to study is this 4x minus 10 creature. It's the only thing that matters. And so what we really gain from this is we gain two things. And now we're done. We verified it. So we conclude D is decreasing. I spelled that really bad. D is decreasing up to 5/2 and increasing after. So what does that mean? Thus, x equals 5/2 is the min. In fact, it's an absolute minimum. So I didn't make a sign chart per se. I didn't even need to talk about the domain per se. But what I can reason just in this is all I need. I need that it's always decreasing. Well, you guys read left to right. So it's always decreasing. Then it's always increasing. So it has to be a min at 5/2. So we're done. Now, what would be useful is we're going to go to Desmos and see that it actually looks like it's the correct answer. But does anybody have a question about this? So what I'd really like you to think about are these subtleties. Notice that I'm not just finding a critical number. That's part of it, but that's not enough. It's to verify that critical number is the absolute maximum or minimum in these problems. Verifying is just as important because I told you this yesterday, and I don't want to do it to mess with your minds, but I can give you a problem where the critical number is a max or min, but actually one of the endpoints is the correct answer. I'm not going to do that to mess with your head, but it's possible. So what I'm saying in the real world is it's not always like this one is the correct one you're looking for. So you need to verify logically. Okay, that said, if we even go back to our original picture, 5/2, now on this picture, it doesn't look correct, right? But I didn't draw this to scale, did I? No, I didn't. This is definitely not to scale. So 5/2 is what? Well, that's 2.5. That would be over here. So let's go to Desmos and let's look at it to scale and make sure that the answer we got, at least we think, is correct. So we'll go to Desmos. I should share this for anybody who's at home. They're not watching now, but maybe later. No one likes us. So the line we're looking at is x plus 5, which is this. Let's make it bold. I'm going to zoom out a little bit. And then what are the operative points? The operative points we're looking for is 10, 0, which is right there. And then I'm also looking at the point, what was it, 5/2. And then what is the corresponding point? Well, the corresponding y value would be 5/2 plus 5. So that'd be 5/2 plus 10/2, which would be 15/2. And of course, once I graph that, that looks a little more realistic, does it not? So this point right here, you know, at least if we look at the graph, this looks to be the correct one. By the way, what we can do is if you wanted, we can graph a line that goes through there and you'll notice, watch the slope I use, negative. So how do you graph this line? It'd be y minus 15/2 equals, what would the slope be? The slope would be -1 because the slope of the line is 1. So it'd be the inverse with minus sign. So, and then this would be x minus 5/2. And what you'll notice is the lines are perpendicular. So the way to solve this problem geometrically without using calculus is to draw triangles. And then you use basic facts of triangles that the length of the side is, the hypotenuse is always longer than the legs. So there's some, you could definitely do it using geometry. And perhaps maybe some of you did that if you had some interesting geometry classes in high school. But in my experience, most people don't teach geometry like that. I don't know how they do it in high school. I feel like most students have very limited knowledge of geometry. which is a shame. Of course, not to you. You're probably like, thank God. And I'm like, what? Who doesn't? That's what Thomas Jefferson and Napoleon would do for fun. They would try to read and learn all the classical math knowledge. Is the election over yet? I think it is, actually. Well, depends. Trump's going to sue, I think. Does anybody have a comment or a question about this? What time are we supposed to have class to? 11:45. I always forget this, right? Is it 45? Yeah. Let's try to knock one out, another similar one. This is a famous problem you may have seen in like a physics class before. Here's coolness. I love stuff like this. So let's, I don't want to write the English because it takes too long, but let's just see if we can draw a schematic first. So let's consider this figure. I got it. Your boy, I cannot draw straight lines if my life depended on it. I'll tell you what. So let's make it like this. We'll make everything positive to be easier. So let's pick, the point. We'll call this 1, and then how about, for fun, we'll call this 1, 10. And then we'll come, excuse me. I'm dying. Let's come out here to 8. And we'll call this point 8, 5. And so what we'd like to do is we would like to, I'm going to draw, what color should I use? I'll use red. I'll take a, so we want to know the point, and I'll draw it so it looks correct. So I'd like to know this point has coordinates x, 0, does it not? It's on the x-axis. Its point would be x, 0. So here's the question. What you'd want to do is determine x so that the distance from 1, 10 to x, 0 to 8, 5 is minimized. So you could imagine that the shortest way to get from 110 to 8, 5 is a straight line, but we can't do that. We have to go somewhere else first. So this is a very, very simplified version of like, hey, I want to go from point A to point B, but I got to go to point C first. What's the quickest way to do it? What's the shortest path? And the reason I said you might have seen this before from physics classes, when you study optics, and maybe you did this in like a high school science class, they talk about light takes the shortest path. Like, so if light wants to go from one place, it goes straight, right? Maybe you already knew that. And then if you imagine this, that the x-axis is a mirror, how does the light go? And we want to, what's the path the light takes or something like that. Maybe you even know what that's called. Has anybody ever seen this before by any chance? What's called is Fermat's principle. And the more general case is if, and you've actually seen this in action before, probably if you've ever been like outside of a swimming pool and someone's in the pool and like half of them's above the water and the other half's not. And like when you look at them, it looks like their lower half is not attached. So you ever notice stuff like that in water? It's because the way that light reflects when it hits different mediums. So anyhow, this is a very elementary scenario that, you know, maybe if you haven't learned about it, you'll learn about it in physics one day. All right, anyhow, we could solve this using geometry. There's a lot of cute ways to solve this, but what we're going to do is we're going to solve it using calculus, because why not? So how do we do this? Well, we need the distance function again, right? So we need our distance that we're interested in. First, we have the distance between 1 comma 10. So this is 1 minus. So if you go back to the picture, the x, first you have 1 and then it's minus x. Yikes. But we can flip that because it's squared. So what we're going to do is we're going to write it like this so there's not so many negative signs. So we'll do this as x minus 1 squared plus, and then what's the y coordinate? Well, that would be 10 minus 0 squared. And then the other guy we could write as x minus, did I use 8? Forget already. Yeah, x minus 8 quantity squared, and then the y distances would be, what are the y distance? Once again, it's, this time it's 5 minus 0 squared. So this cleans up, it's not too bad, and it's clearly already a function of x, which is nice. So this is x squared minus 2x plus 1, but this is also 100, so this is plus 101. And then this guy is x squared minus 16x. Then you get 64 plus 25. Well, 64 and 20 is 84, and then 84 and 5 would be 89. So I don't think I made any mistakes. And then you would imagine that this guy, we're going to reason this guy the same way we reasoned the previous problem. Only now we have to calculate a little bit more of a derivative. So this was going to be so this will be 1 over 2 times, again, blah. Well, I guess we shouldn't do blah now. We have to be a little more careful now because we're going to have 2 nonsense. So let's write it down just to be careful. It might matter here. We're running out of time, so who knows. So this is x squared minus 2x plus 101. And then, of course, the derivative of this is just 2x. I'll write it up top. It's 2x minus 2. And then this piece is 2 over x squared minus 16x plus 89. And then up top is 2x minus 16. Now, we need to determine when this thing is equal to 0. That's an ugly algebra problem. And we can't get the short reasoning we were able to do on the previous problem. So, because we have 2 terms. And in order to do that, we would have to find a common denominator. Like we're going to have some work to do. So the thing to note is, let's put it this way, we're out of time. So can you solve d prime of x equals 0? Maybe you can, maybe you can't. I don't know. Here's another way to think about it. And I can ask you this too. Is there a better way to set the problem up? Anyhow, think about that. We're out of time. Thank you for coming. Hopefully, I'm going to post an assignment and another one of the a little short quiz. It'll be due early next week. The quiz will maybe take you 5 minutes, 10 minutes tops. So, all right, if you guys don't have any questions, I say bye. If you do have questions, I'll answer them. Uh, Any questions, comments?